Analysis of cadmium pollution at the plantation of water spinach. And next, before entering the topic, I'm going to brief through the table of content. So first, we are going to have introduction, and second, extraction technique, which is solid phase extraction, SPE, and next, chromatography technique, HPLC, high performance liquid chromatography. And next, which is conclusion. So for introduction part, the problem need to be solved is that the pollution caused by cadmium accumulation in water spinach or kangkong plantation. The objective of this problem solving is to overcome the pollution problem and to identify the concentration of cadmium by using extraction method and chromatography technique. And why? Why cadmium will accumulate in water spinach? This is because the application of water spinach as a biological treatment in phytoremediation to treat wastewater, and it uses natural processes and unlikely to leave toxic substances. We have found a case study which is occur at Pantai Tengah, Langkawi, and it is about kangkong as an absorber for cadmium and also serve as an alternative for phytoremediation or metal contaminated aqueous medium due to its very good metal uptake ability to ensure that the quality of water flow to sea is clean and without heavy metal contaminant. To determine the concentration of cadmium, we have to use solid phase extraction SPE to extract and purify cadmium sample for analysis and also use high performance liquid chromatography HPLC to identify and quantify cadmium in the mixture. So for the effect, water pollution caused by the heavy metal can greatly affect the life of wild water spinach. The metal effect of cadmium on the health status, growth, anatomy, and DNA quality of water spinach was studied. Consequently, human health can be threatened and cause health risks when the cadmium-contaminated water spinach was forage consumed. So basically, the plant is not recommended for human consumption as its ability to retain heavy metal in their edible parts. So there was a brief introduction on analysis of cadmium pollution at the plantation of water spinach.
For sample preparation, first, the water samples were collected in clean polyethylene bottles. Before the water samples were collected into the bottles, it will first pass through a layer of filter paper to filter out debris. Next, the treatment of sample water will be carried out immediately by acidification to pH 2.0 with nitric acid to prevent absorption of metal ions on the flux wall.
The extraction method we are using to extract the cadmium from the sample solutions is the solid phase extraction technique. But instead of using the traditional SPE technique, we decided to use a new, simple, and more rapid method, which is using nanoparticles. In precise, this is done by immobilizing 2-mercaptobenzothiazole MBT and sodium dodecyl sulfate SDS on magnetite nanoparticles. This forms an adsorbent that is called MBT SDS magnetite nanoparticles. The method is based on the extraction of cadmium ions via complexation with MBT immobilized on SDS-coated MNPs. There are two major steps in preparing the adsorbent. The first is the synthesis of MNPs, magnetite nanoparticles. As a first step, the magnetite nanoparticles were prepared by a chemical co-precipitation procedure. 8.5 gram of iron 3 chloride hexahydrate and 3.0 gram of iron 2 chloride tetrahydrate were dissolved in 38 ml of 0.4 mol hydrochloric acid solution. Chemical precipitation was achieved under vigorous stirring for 30 minutes by adding 375 ml of 0.7 mol ammonium hydroxide solution. During the whole process, the solution temperature was maintained at 80 Celsius and nitrogen gas was purged to remove the dissolved oxygen. After the reaction, the nanoparticles were collected by a magnet and thoroughly washed with deionized water to remove excess amounts of ammonium hydroxide. Then, the nanoparticles were dried in an oven for 5 hours at 110 Celsius. The second major step in preparing the adsorbent is the preparation of MBT/SDS magnetite nanoparticles. 10 ml of 3% weight volume concentration sodium dodecyl sulfate SDS solution and 10 ml of water containing 3 grams of MMPs were placed in the beaker. The mixture was stirred at room temperature for 4 hours. Then, 50 ml of 0.4% weight volume concentration thiomercaptol benzoyl MBT solution was added to SDS MMP's solution, and the mixture was stirred for 12 hours. Finally, after mixing, magnetite nanoadsorbents MBT/SDS MNPs were separated from the solution using a magnet and then washed 3 times with deionized water and dried at room temperature. With the adsorbent prepared, we are ready to carry out the extraction procedure. First, 50 ml of the sample solution was transferred into a beaker. 1 ml of 10% weight volume concentration sodium chloride solution, 5 ml of distilled water, and 20 mg of sorbent were added to the solution. The pH of the solution was adjusted to 8 using 2 ml of 0.1 mol per liter phosphate buffer, and the mixtures were dispersed by ultrasonication for 10 minutes at room temperature. Then, the beaker was placed on the magnet and the adsorbent containing adsorbed cadmium ions was collected. After decanting the supernatant solution, the magnet was removed and a solution containing 1 mol per liter of nitric acid in methanol was added as eluent and ultrasonicated again for 5 minutes. Finally, the magnet was used to collect the adsorbent and the eluent can be analyzed using HPLC.
After extracting the metal sample by using SPE or solid phase extraction, we will be moving forward to HPLC or high performance liquid chromatography. This instrument and method is needed to quantify and identify the sample metals in the mixture. This is an overview of HPLC. Firstly, a solvent is needed to create a mobile phase. The mobile phase is needed to transport our sample throughout the HPLC system. To create a mobile phase, we need a pump. The pump moves the solvent continuously from the flask to the waste can. After that, to measure the sample, we need an injection system to inject the sample to the mobile phase. The identification and quantification of the component will then happen in the column. This is what the inside of the column looks like. When sample reaches the column, it leaves the mobile phase and enters the stationary phase. The stationary phase is the substance fixed in place for the chromatography procedure. This is where the separation takes place. After leaving the stationary phase, the sample moves through a detector. The detector sends the signals to a software on the computer, which then converts it to chromatogram. This is the chromatogram. The number of peaks can indicate how many components are in the mixture. The y-axis shows the absorbance, while the x-axis shows the amount of time for the analyte to pass through the column and reach the detector. This also could show the amount of specific analyte that's present in the mixture. In conclusion, we use SPE, which is solid phase extraction, and HPLC, high performance liquid chromatography, to detect the pollution caused by cadmium accumulation in water spinach plantation. Both of these methods are very fast and efficient. HPLC has a high sensitivity that could lead to a very accurate quantitative measurement. It is also possible to analyze multiple components of a mixture in a single analysis. Thank you.